In this section, we're going to do a graph of a function that we haven't really quite seen yet. So the function, this will be an example of one that we'll try to graph. 2x minus 1, x is less than or equal to 3, x is bigger than 3. So what this means is that there's two different functions that we can choose when we're plugging in a number for x. So just in a previous video or whatever, we might have seen a function like x squared plus 3. And when we're plugging in a number, say plugging in 4, all we do is just plug in 4 for x. So you have 4 squared plus 3. So that's 16 plus 3, which is 19. But say if we want to do it for this problem. Okay, so we're plugging in 4, but there's two equations to choose from. We can either plug it into this one or we plug it into this one. But this is where then we have to look at this thing now. So this is telling us when we're plugging in numbers less than or equal to 3, we use this equation. And then when we plug in numbers that are bigger than 3, we use this equation. So for example, with this one right here, f of 4, 4 is bigger than 3. So we're going to plug it into this equation. So this equation is just f of x equals x. So if we're plugging in 4, we're just going to put a 4 here. So this is going to be 4. For example, f of 16. Again, so 16 is not less than or equal to 3, so we're not plugging it into here. But 16 is bigger than 3, so we're plugging it into this equation. And this equation, so f of x equals x, so think of it now as just like this. F of x equals x, so whatever you plug in here, you're going to put right here. So we're plugging in 16, then we're going to get 16. Maybe like f of minus 10. So now, again, so minus 10 now is not bigger than 3, so we're not plugging it into this equation. But minus 10 is less than or equal to 3, so we're going to plug it into this equation. So we'll get 2 times minus 10 minus 1. So all we're doing is replacing this x with a minus 10. So this is going to be minus 20 minus 1, which is minus 21. And just one more example like this. We can have just more than two equations in here. So for example, f of x equals 2 when x is less than or equal to negative 10. X squared minus 1. So this is telling us now then that this equation, if we plug in a number that's less than or equal to minus 10, it's just the number 2. If we plug in a number bigger than minus 10, but less than or equal to positive 10, it's going to be this equation. If we plug in a number that's bigger than 10, it's just going to be 15. So for example, f of negative 99. Well, negative 99 is less than or equal to minus 10. And this number you're plugging in is only going to satisfy one of these things. So for example, minus 99, that's less than or equal to minus 10. Minus 99 doesn't work with this one, and it doesn't work with this one. So this is going to be the equation for this. But this is telling us no matter what value we plug in this section, it's just going to be 2. So the answer is 2. F of 0. So f of 0 is 0 is in between minus 10 and 10. So we're going to plug 0 into this equation. So we're going to get 0 squared minus 1, which is just equal to minus 1. And let's say like f of 50. Well, 50 is bigger than 10, so we're just going to use this equation. So whenever you plug in a number bigger than 10, the answer is just 15. Okay, so now in this next example, let's see how we can graph an equation that looks like this. So let's do a couple of examples. For the first one, let's graph this equation. 2x minus 1, x is less than or equal to 3, x plus 1, x is bigger than 3. So we need a graph. Let's put this down here. Let's put some. So when we're graphing this, the first thing we want to do is over here you're going to see some numbers. In this situation, we only see the number 3. And what we're going to want to do is plug the number 3 into both these equations to see what we get. So first, let's just do this equation, 2x minus 1. When we plug in x equals 3, so we're going to get 2 times 3 minus 1, which equals 5. Okay, so that's good. Now let's do the same thing to this next one, the x plus 1. So if we plug 3 into this one, we get 3 plus 1, which equals 4. All right, so before we continue, let's do something with these two numbers. So think of this as like an x value and a y value. We plug in x is 3 and we get 5. Here we plug in x is 3 and we get 4. But if you look up here, how this says x is less than or equal to 3. So 3 is less than or equal to 3, since 3 is equal to 3. So we can plug 3 into this equation. But for example, you see down here we plugged 3 into this one. But 3 is not bigger than, 3 is not bigger than 3. So technically we're not allowed to plug 3 into this equation when we're using this. But so what we're going to do now then is we still want to point both of these dots, or these points, the 3, 5 and then the 3, 4. The one that has the greater than or equal to sign, that's going to have a closed dot. So for example, this 3, 5, so here's 3, let's draw a better graph. So for example, the point 3, 5. Right here, this is going to get a closed dot. And then this point right here, 3, 4, because the 3 has the less than symbol, not the less than or equal to symbol, we're going to get an open dot on this point, 3, 4. So here's 3, 4. Okay, so now after we do that first step, so the first step is we just see this number over here and we're going to plug that number into both of these equations. Now what we want to do is, well, so for this equation right here, this is for numbers less than or equal to 3. So let's just choose another number less than or equal to 3 to plug into this one. So for example, 0. So if we plug in 0, we get 2 times 0 minus 1, which is equal to minus 1. So we get the point 0 minus 1. So here's 0 minus 1. And we're putting a closed dot because we're allowed to plug in 0 to this equation. So we can plug in 0, and when we do, we get minus 1. So here's the point 0 minus 1. And then the next step is, once we do that, we're going to connect these 2 points together. So the 0 minus 1 with the 3 and 5. So like this. And we're going to draw an arrow going off into this direction. And again, we're drawing an arrow off into this direction because we can't go any more in this direction. That's because when we go more into this direction, x is becoming bigger than 3. And this equation right here is only for x less than 3. So now we're going to do the same thing for this the other equation. So now, like before, in this one, we just picked a number less than 3 to plug in. Now we're going to pick a number bigger than 3 to plug into this equation. So how about like 5? X equals 5. If we plug in x equals 5, we get 5 plus 1, which equals 6. So the point 5, 6. So here's 5. And we're putting a closed dot on this one. And a closed dot because we're allowed to plug in 5 to this equation. 5 is bigger than 3. We plug 5 into here. We get 5 plus 1, which is 6. And now what we do, we're just going to connect these 2 dots together, the 3, 4, and the 5, 6. So here's the 3, 4. Here's the 5, 6. And we connect those 2 together and draw an arrow off in this direction. And so for this example, this is how we would graph it. So again, you start by, over here, you see these numbers. You're going to plug those numbers off into the left. And sometimes you'll get an open circle, sometimes you get a closed circle. For example, if we plug in 3 to this one, which is what we did right here, we get a closed circle. Let's put like a dot right there. But when we plug 3 into this one, we're not allowed to plug in 3 because 3 is not bigger than 3. So for that reason, we're going to get an open circle. But then for this one, we want to pick 2 more points in this section. So another point to the left of 3 is going to be 0. So we're allowed to plug in 0. That means we get an open circle, or sorry, a closed circle. Here we're plugging in 5 to this bottom equation. Again, 5 is bigger than 3, so we're allowed to plug 5 into this one. For that reason, we're getting a closed circle. Then you plot both of these points, the 3, 5, 0, minus 1, 3, 4, 5, 6, just like we did over here. And you connect all the points that are in the same table. So this 3, 5 and this 0, minus 1, 3, 5, 0, minus 1, they're in the same table, so we connect them. This 3, 4, this is an open circle, not a 0. So this 3, 4, 5, 6, right here, the 3, 4, and the 5, 6, they're in the same table, so we can connect those 2 points. Okay, let's do one more example like that. Okay, so now in this equation, we have 3 separate pieces, whereas before we only had 2 separate pieces. And pretty much we're still going to be doing the same thing. Let's just draw a graph that we're going to want. Okay, so before we started we looked over here, we saw what numbers we see, and then we plugged those numbers in over to the left, and we're still going to do the same thing. So let's take this first equation. We're going to have a table for the equation 1, we're going to have a table for the equation x plus 1, and we're going to have a table for the equation x minus 5. So like we said before, whatever we see to the right, that number, we're going to plug it into here. So what happens when we plug in minus 4? So first of all, minus 4, since we have the this or equal to sign on the minus 4, when we plug minus 4 into this side, we're going to get a closed dot. But this is saying that it's 1. So whenever you're plugging in a number less than or equal to minus 4, you get the number 1. For example, if we plug in x equals... If we plug in x equals minus 4, well, minus 4 is less than or equal to minus 4, we just get 1. If we plug in a number less than or equal to minus 4, so let's say let's plug in minus 6. Again, if you plug in minus 6 to this equation, you're just going to get 1 again. So it's always going to be 1. So now let's look at this middle one. So before we only had one number to plug in, now we have 2 numbers. So we want to plug in both of these numbers. So let's start with plugging in the minus 4. Oh, let's do the closed dot thing too. So this one's going to get a closed dot over here, and this one's going to get a closed dot. Again, we're going to get a closed dot on the minus 4 because the minus 4 has the greater than or equal to sign. And then the number that we picked to the left of minus 4, we're allowed to plug that in here, so that's why this one also has a closed dot. Now for this one, x equals minus 4. Minus 4 is not bigger than minus 4, so technically we're not allowed to plug it in here. But we have to do that anyway to complete the steps. So if we plug in minus 4 to this one, we're going to get minus 4 plus 1, which is minus 3. But because we're not allowed to plug in minus 4, this one gets an open circle. And now we plug in this other point, 4. We'll get 4 plus 1, which is 5. But we're allowed to plug in 4 because 4 has the less than or equal to sign. So this one gets a closed dot. And you only need 2 points per table. So technically we don't need to plug in a point in between minus 4 and 4. We just need to make sure we have 2 points per table. Okay, so now let's do the x equals minus 5 one. So we want to plug in this number over here, 4. Let's write this table down here where we have more room. So if you plug in 4, you get 4 minus 5, which is minus 1. Now, we're not allowed to plug in 4 because 4 is not bigger than 4, so this one gets an open circle. And now let's plug in another number just to the right, a number that's bigger than 4. So let's plug in 6. If we plug in 6, we're going to get 6 minus 5, which is 1. And that's a closed circle because we're allowed to plug in 6. So now what we need to do is we need to put all these points on our graph and then connect them all. So here's the point, minus 4, 1. So minus 4, 1, and that has a closed circle. And here's the point minus 6, 1, and that also has a closed circle. Then connect them like this. And again, we're drawing it this way because this equation is only for x less than or equal to minus 4. So here's minus 4, the x value, and this equation right here is only for the values less than or equal to minus 4. So now let's do the middle equation. We have minus 4, minus 3. So here's minus 4, minus 3, and we put an open circle here, which is what the thing says. So minus 4, minus 3. And then also 4, 5. So here's 4 and 5, and we put a closed circle there. And for this one, there's no arrows. All we do is connect the 2 dots. And that's because this middle equation is only for x values in between minus 4 and 4. So x values in between minus 4 and 4. So for example, this one is x values less than minus 4. So there's an infinite number of things less than minus 4. So that's why we have the arrow. It just keeps going on forever. But this middle equation is only for minus 4 to 4. So we're drawing a line like this. And now let's do for the next table. We have the point 4 minus 1, and with an open circle. And then we have the point 6, 1 with a closed circle. And then connect those two. And so that's how we would graph one that has 3 equations. So this last thing, this is just kind of like a little definition, something called the vertical line test. So say if we have just, there's 2 graphs, something that looks like this, and then maybe one that looks like this. So here's like your x-axis, your y-axis. So we want to know if we have a graph, is there a function is the graph describe a function? And basically what that means is if we have a graph, we want to know, does it pass the vertical line test? And what the vertical line test is if you're given a graph and you draw vertical lines, it can only touch the graph in one spot. So for example, on this one, any vertical line we touch or draw, it only touches the graph in one spot. Over here, if we draw a vertical line, it touches it in 2 spots. So for example, this one passes the vertical line test. And this one fails it. So what that tells us is that this one right here is a function. And since this one fails, this is not a function. So really, I think that's all that you guys need to know about this. It's really nothing special. It's just, you have a graph. If you draw vertical lines and it touches it in one spot, then the graph is a function. But if you draw a vertical line and it touches it in 2 spots, then the graph is not a function.